Dear students, today we will talk about hybrid proofs. But to talk about hybrid proofs, we will use an example. And one of the main uses of the hybrid proofs is when there is a repetition of some underlying primitive. So for hybrid proofs, today what we will do is we will convert a pseudo-random generator that has n plus 1 bits of output to another pseudo-random generator that has n plus some, let's say, pn, where p is a polynomial bits of output. So we are extending the output length of a pseudo-random generator. Remember, this pseudo-random generator with n plus 1 bit output, we know how to create using, for example, a one-way permutation, let's say, that has an n bit output, plus the hardcore bit associated with that one-way permutation. So we can do this, we know how to do this. Now from n plus 1 bit output PRG, so a PRG that essentially gives one more, let's say, pseudo-randomness to us, we will obtain polynomially many pseudo-random bits. The construction is extremely simple. So remember, the PRG needs to start with n bits of pure randomness. Okay. So now what we are going to do is, let's say our n plus 1 bit PRG is called gn plus 1. So its domain is n bit values and its range is n plus 1 bit values. Now using this, we will run this once. So let's run gn plus 1 on this n bit random value. What will it give us? It will give us n plus 1 bit output. Okay, so we start with n bits of randomness here. We now have n plus 1 bits after running gn plus 1 once. Now we will take the first n bits of this. We will run gn plus 1 again. What is it going to output? It will again output n plus 1 bits. So n bits here, 1 bit here. And then we will copy this 1 bit here. Okay? So essentially now we have n plus 2 bits. After running gn plus 1 twice, we have n plus 2 bits. Now let's run this gn plus 1 one more time. It will again give us n plus 1 bit output. So n bits here, 1 bit here. Then we will copy these 2 bits here. Okay. So in total we have n plus 3 bits now. If I continue running gn plus 1 on the first n bits of this value, eventually what I will obtain is, if I run this in total pn many times, I will obtain n plus pn bits at the end. So remember what we said? If I run gn plus 1 once, I have n plus 1 more bit. If I run gn plus 2 twice, I have n plus 2. If I run it 3 times, I have n plus 3, which means if I run it pn times, I will have n plus pn. Now with these, what we are going to construct is the following. Our goal is to construct g, let's say n plus pn. This is a new pseudo-random generator we are constructing. Its input is n bits random value, and its output will be n plus pn bits of pseudo-random value. So if I run gn plus 1 essentially Pn times using these first n bits of the result, okay, and then keep the extra bits here. This will give me my construction for Gn plus Pn. Remember, P is a polynomial here. So by running this pseudorandom generator that has n plus 1 bit output, Pn many times, I am going to obtain Gn plus Pn. And if this Gn plus 1 is a polynomial algorithm, okay, this whole Gn plus 1 will take polynomial time.